Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 7C, Proportion Direct Applications, Part 1.
Hola, alumno. Today we shall study some Mexican dishes. Invertendo, alternando, componendo, dividendo, and also componendo and dividendo. In invertendo, we just reciprocal the ratios. In alternando, we exchange the numbers. So B goes up here and C goes down. We've been doing this often, but we never knew that they had names. Componendo means if A upon B is equal to C upon D, then A plus B upon B will be equal to C plus D upon D. That means numerator plus denominator upon denominator is equal to numerator plus denominator upon denominator. Instead of addition, if we use subtraction, we call it dividendo. And the thing which we'll be using most often in our exercise today is componendo dividendo. That is, if A upon B is equal to C upon D, then numerator plus denominator upon numerator minus denominator is equal to numerator plus denominator upon numerator minus denominator. Let me prove this to you. Now we know that 1 upon 2 is equal to 4 upon 8. So if I apply the operation of componendo dividendo, it means 1 plus 2 upon 1 minus 2 should be equal to 4 plus 8 upon 4 minus 8. Now calculate the LHS and RHS and check, is it really true? It would be. In SE number 26, cancel the alternative method. In SE 30, also cancel the alternative method. Exercise 7C. First, note down all the cancellations and IMPs. 1.1 is cancelled. Question 3 is cancelled. Next, question 6.2 is IMP. Question 8 is IMP. Question 10.2 is IMP. Question 11.2 is IMP. Question 13 is IMP. Let's start with question 1.3. It's given that A ratio B is equal to C ratio D, or A upon B is equal to C upon D. And we have to prove this. So we are going to use the K method. Now this is not a continuous proportion. So A upon B is equal to C upon D is equal to K. So C is equal to DK and A is equal to BK. We can't say A is equal to DK squared. That is only possible in continued proportion, which this is not. So I got two values here, C and A. We'll start with the LHS. This was the LHS. We will substitute the value of A and C. That's what we've got, right? So that now everything is in terms of B and D only. A and C have disappeared. Good. Now remove B common in the numerator and D common in the denominator. So the brackets get cancelled and we get this, and this is the RHS, hence proved. Next, question 2. Again, it's given A upon B is equal to C upon D, and we have to prove this. So we shall use the K method. Notice how this 6A 7B here relates to the 6C 7D here. So there could be some alternative methods also, but the K method is the easiest. So just stick to this. We'll start with the LHS. Notice how C became DK and A became BK. So we will simply substitute this in A LHS and B RHS, and automatically we will realize that the final answer is the same. Let's check. So instead of A, I'm writing BK, and wherever there is a C, I'm writing DK. Now here what is common? B is common. Take it out of the bracket. Here what's common? D is common. Take it out of the bracket. Let's write it in the beginning. So this is what is left. We can't do anything more. Don't open the brackets unnecessarily. Now do the same thing in the RHS. Substitute the value of C and A and take out D common from here and take out B common from here, and we are actually left with the same thing. So LHS is equal to RHS, hence proved. Next, question 4. Here it is given that this upon this is equal to this upon this, and we have to prove x upon y is equal to u upon v. So here clearly we can't use any k method. It's the reverse of the previous sum. But one interesting thing is that the numbers 5 and 6 are repeated. So that's a big hint that we should use something called componendo dividendo. Let me show you how that works. First of all, make sure that the numerator and denominator have the same variables. This is x and y and this is u and v. No. Let's do an alternando. This will go up here and this will go down here. That way, now it's xy, xy and uv, uv. And always you will get plus and minus sign, opposite signs. Because now if I do componendo dividendo, and you have to mention that by componendo dividendo, or you can simply write it here by componendo dividendo. But if there is no space, it's better to write it in the beginning itself. So what does componendo dividendo mean? The numerator plus the denominator gives you numerator minus denominator. Since I have not written the brackets, I have taken care of the signs straight away. Notice how these two signs will change because it's minus 5x and then minus into minus is plus. So if you can't do it directly, use brackets first and then solve. I remember it like this. Whatever signs were there in the numerator for these two terms, write the opposite sign. So this plus will become minus and minus will become plus. Same way on the RHS. The numerator plus the denominator, and in the denominator the numerator minus the denominator, but I've opened the brackets, so this sign and this sign has changed. It was 5u minus 6v. I'm writing minus 5u plus 6v. The beauty of componendo dividendo in such a situation is always this will get cancelled, this will get cancelled, this will get cancelled, and this will get cancelled. So what I'm left with is 5x plus 5x is 10x, 6y plus 6y is 12y, 5u plus 5u 10u, and 6v plus 6v 12v. And now 10 10 cancelled, 12 12 cancelled, and I get what is asked by using componendo dividendo. Now the 6.2 sum, which is IMP, this is what is given and we have to find the value of this. Seems complicated? Well, we'll find this value first, we'll find this value second, and then we will add the two values. So we'll solve it in parts. But how to find this value? Notice a plus 2 root 2 and a minus 2 root 2 looks like something similar to componendo dividendo here. You know, numerator plus denominator upon numerator minus denominator. Even here, numerator plus denominator upon numerator minus denominator. It's the same terms and opposite signs. So that's a big hint that we have to use componendo dividendo in this sum. But what is the starting ratio then? Here I can see that root 2 and root 3 both are present. And even root 6 can be split into root 2 into root 3. Now that's when it should strike you. This is a kind of sum where we split the given values. This will become 2 into 2 into root 2 into root 3. Now what if I bring this 2 and this root 2 down like this? So 2 into root 2 goes down below a. What is left? 2 root 3. That's good because that's what we have here. If I do componendo dividendo of this a upon 2 root 2, it will become a plus 2 root 2 upon a minus 2 root 2, like this. On the other hand, what if we would have brought this 2 and this root 3 down below a? So it will become a upon 2 root 3, and what is left in the numerator here? 2 root 2 is left. That's good because now if I have this ratio, what if I do componendo dividendo? I will get a plus 2 root 3 upon a minus 2 root 3, which is what is there in the question. So now we will solve them separately. We will apply componendo dividendo in both the cases, here as well as here. And notice, if you're doing componendo dividendo in the LHS, same thing should happen in the RHS as well. Even here LHS, RHS, in both cases it will happen. Then only it is valid. So we'll write the heading by componendo dividendo. Make sure you always mention that compulsorily. So I get numerator plus denominator upon numerator minus denominator is equal to numerator plus denominator is equal to numerator minus denominator. And notice how this sign changed because of the minus sign here. I just opened the bracket directly, but you may do step by step. Even out here I'm solving simultaneously. I like to do that. You could have solved it one below the other as well. Numerator plus denominator upon numerator minus denominator is equal to numerator plus denominator upon numerator minus denominator. And of course the sign changed because the brackets were opened. So I got 2 root 3 plus root 3 is 3 root 3 plus root 2 remains as it is, can't do much about it. And 2 root 3 minus root 3 is 1 root 3. So 1 root 3 minus root 2. Similarly here, 2 root 2 plus root 2 is 3 root 2 plus root 3 is remaining. And 2 root 2 minus root 2 is 1 root 2 minus root 3 also. So that's what I get in the end. I got the value of this ratio and the value of this ratio, and now if I add them, if I add this plus this, then the answer is this plus this. So you can write from equation 1 and 2, on adding equation 1 and 2 you get this. This was the question, check it out. So now how to solve this? Well, if only the denominators were same, then I would just bring them together. I don't want to do any LCM or rationalize the denominator. It's not required. The denominators are almost same. If I could just flip it, instead of root 2 minus root 3, can I just write it as root 3 minus root 2? Yes, you can, but then you have to change the sign. Okay, I'll do that, minus sign. At least my denominators are same now. I can bring the numerators together, but when you bring the numerators together, this minus sign will change this sign as well. Imagine this was in bracket and there is a minus sign outside, so this sign will change. Be very careful about the signs. The sums are so easy, but sign errors are the #1 common errors in this chapter. So I get this in the numerator. Now let's add root 2 minus 3 root 2 is minus 2 root 2, and 3 root 3 minus 1 root 3 is 2 root 3. So I am left with this. Remove 2 common and the brackets get cancelled, so the answer is 2. The answer is just 2. Who would have imagined that the answer of such a complicated question is just 2? Now the 8th sum, it's an IMP sum again. This is what is given, and we have to show that this is equal to this. So can you guess what will you do in such a case? Don't try to cross multiply. There are 4 terms into 4 terms. That's not possible. Use some operation. Which one is a favorite operation? Componendo dividendo. Definitely, automatically you will get the answer. If not, then we'll do it once again. So numerator plus denominator is equal to numerator minus denominator. Notice how because of the minus sign I have already opened the bracket and changed all the signs. Don't forget to do that, and make sure you write componendo dividendo. So again, numerator plus denominator is equal to numerator minus denominator, but here the signs will change. And now things will get added or subtracted. I think B is getting disappeared here, even D is getting disappeared here, and here C is getting disappeared, and A is getting disappeared, and same way even here B is getting disappeared, D is gone, and here A is gone, and C is gone. And that's the whole point of doing componendo dividendo, so that things can get cancelled. And the biggest hint is that when you look at numerator and denominator, you see the terms are same and the signs are opposite. That's the whole hint. So what is left? A plus A, 2A minus 6C upon minus 4B plus 8D. And in the RHS, I'm left with 2A plus 6C upon minus 4B minus 8D. Now what to do? I told you, if you're not getting the answer, do the componendo dividendo once again. But for that, I need the same terms one below the other. So first I'll have to do alternando. That is, this will go down here and this will go up here, because then only I will have A and C in numerator denominator and D and B in numerator and denominator. So now do componendo dividendo. Please write it. CD. Don't write CD. CD is not allowed. You have to write the whole thing. Componendo, dividendo, everywhere. Yes, no shortcut. So numerator plus denominator upon numerator minus denominator. Change the signs. Numerator plus denominator. Numerator minus denominator. Change the signs. Yep. Minus into minus became plus. And minus into minus became plus. So again things will disappear. C getting disappeared, A is getting disappeared, D is getting disappeared, and B is getting disappeared here. So we are left with this. Cut the numbers, cut. We are left with this, and if you cross multiply, you get what is asked. Minus sign also gets cut, correct? Or you can just think of it like this: when minus goes up here, minus into minus is plus. Ninth sum. If this into this is equal to this squared, prove A upon X is equal to B upon Y. Ratios are not given, ratios has to be proved. So how do we solve such a sum? I guess the only thing left to do is to open the brackets on the LHS and even the RHS. Let's see what happens. So distributive multiplication A square into brackets plus B square into brackets is equal to, if I use the formula A plus B the whole squared, that is A squared plus B squared plus 2AB. That is, this entirely is A and this entirely is B. That's 2 into ABXY. That's how I got this. Again, distributive multiplication, A square into X square plus A square into Y square plus B square into X square plus B square into Y square. I get this. Oh lovely, this is getting cancelled. I love it when things get cancelled. So I'm left with two terms and one term here shifted to the LHS. This looks like some kind of formula. Isn't this AY the whole square plus BX the whole square minus 2AY BX? That is, this is of the format A squared plus B squared minus 2AB. So this is a formula, A minus B the whole squared. Open this bracket and check. Won't you get this thing exactly? But how would you know that this is a formula? Well, you would know by seeing it. Can't you see it's a formula? With practice, you'll be able to visualize that, and it'll strike you. Now this is equal to 0. That's nice. So the square will become square root, and square root of 0 is 0. If AY minus BX is equal to 0, then shift minus BX to the RHS, it becomes AY is equal to BX. Then rearrange the terms. It's called A upon B is equal to X upon Y. How? Which operation is this? This is called common sense. Next, 10.2. It's an IMP sum. So A, B and C are in continued proportion. Now that's something new in this exercise. Continued proportion means A upon B is equal to B upon C. So that will assume it to be K. We'll use the K method. We'll substitute in the LHS, we'll substitute in the RHS, and we'll hope that they come out to be same. And if they don't, then you know you'll just force them to be same by manipulation, right? No, don't do that. Because if the steps are wrong, you won't get marks. Since it's continued proportion, I can say that B is equal to CK and A is equal to CK squared. Yes, right. Just like we have done it in 7B exercise. So now in the LHS, we'll substitute these values. Just substitute it and definitely we'll get it equal to RHS. So instead of A, I'm writing CK squared. So this becomes the whole squared. Instead of b, I'm writing ck, so that becomes the whole squared. C remains as it is. Even in the denominator, instead of a, ck, and instead of b, ck, instead of a, it's actually ck squared. So the whole ratio is in terms of c and k. That's nice. Open the brackets first of all. In the numerator, I'm getting this. I can take c square common. So I'm left with this. But now what? This is a trinomial. It's 3 terms. So I don't want to open the brackets with the square formula. Now here's something very new for you. You'll have to learn a new formula today. Whenever you see something like this, an expression of k raised to 4 plus k squared plus 1, remember, this has a formula. We can split it into 2 brackets. If it was a square minus b square, then you know it's a plus b, a minus b. But now we have a special formula for such a scenario. First of all, this gets cancelled, so that's gone. But what is the formula? Well, it is k square plus k plus 1, k square minus k plus 1. You have to learn this formula. This is a very unique sum. There is no alternative method. If you do distributive multiplication of these 2 brackets, you will definitely get back this. And the best part of using this formula is that the brackets get cancelled. That's the whole point. Why did we do it? This was cancelled. How did it come back again? Cancel it again. This is what is left. And of course here there was a square, so only one bracket got cancelled. Okay, the second bracket is still remaining in the denominator. Can we do something else? Nope, we can't. You can't do componendo dividendo here. See, only if there is something on the LHS and RHS both, then we do componendo dividendo on both. We can't do it only on the RHS or only on the LHS. It has to be on both the sides. So leave it like this. And let's hope that the RHS also reaches this same value. So in the RHS, we would substitute the value of A and B, and remove C common. That gets cancelled, and we indeed reach this. Great, so LHS is equal to RHS. Next, 11.2. Again, it's IMP sum. Using the properties of proportion, solve for x. Solve for x means find the value of x. So this is what is given. The moment you saw this, what came to your mind? Componendo dividendo, isn't it? You're loving that dish now. So, same terms are there, signs are different. So componendo dividendo, numerator plus denominator upon numerator minus denominator. The sign has changed. Same way, even in the RHS, don't forget to do it. Don't discriminate between LHS and RHS. Do it on both the sides. So numerator plus denominator, numerator minus denominator, and mention componendo dividendo entirely. Don't write C. Good news. This got cancelled. This got cancelled. So I'm left with this. Root plus root is 2 root. And in the RHS, it's here like this. 2 gets cancelled. Now what? Well, square root will go on the right hand side and become squared. Now we have no choice but to open the brackets. I can't do componendo dividendo because here I have a square involved. First I have to get rid of the brackets and the square. So a plus b the whole square is a square plus 2ab plus b square, and a minus b the whole square is a square minus 2ab plus b squared. Now you can do componendo dividendo. Try it. But I want to show you something else now. I'm doing cross multiplication. Now when I do that, I have to do distributive multiplication, which is such a headache. That's why it's better to do componendo dividendo. But I would like to show you a variety of methods. Hence I'm doing this open the brackets method in this sum. Seems to be a very long equation. Be very careful about the signs. Things will get cancelled, like this and this got cancelled and so on. And I'm left finally with minus 8x is equal to minus 10. Don't just copy it. Actually add and subtract and check it on your own. And now we know how to get the value of x. Minus 8 goes down, minus minus cut, 8, 10 cut, and we get the answer as 5 upon 4. Next, the 13th sum. Using the properties of proportion, solve for x. That means find the value of x. So again, we'll start with componendo dividendo, obviously. Numerator plus denominator, numerator minus denominator, and same thing on the RHS. Make sure you write componendo dividendo. Now this is a perfect square. This is actually, it's actually x square the whole square plus 1 square plus 2 into x square into 1. Check. Isn't this the same as the numerator? So it is a square plus b square plus 2ab. So now we can convert it into a formula a plus b the whole squared, and similarly the denominator is a minus b the whole squared. If you would open this brackets with the square formula, you will get back this. Check it. Pause and check. Don't just blindly copy. Now the square will go here and become square root. You can cross multiply and solve further, but now I would like to do componendo dividendo, please. And here the square root, we don't have to write plus and minus sign. Not required. That is only in the last step of a sum. So by componendo dividendo, I get numerator plus denominator upon numerator minus denominator. So notice how the signs have changed here and here. And same thing on the RHS. 1 cut, x square cut. I'm left with this. 2 cut, this also cut. X square is equal to 4 and x is equal to plus and minus 2. So in the last step, you have to mention plus and minus both. And finally the 15th sum. This is what is given, and we have to show that nx is equal to my. So do componendo dividendo. Automatically you will get it. So numerator plus denominator upon numerator minus denominator. Notice how the sign changed. And same thing on the RHS. Notice how the sign changed and mentioned by componendo dividendo. Now can you see this is actually a formula? A cube plus 3ab square plus 3a square b plus b cube is nothing but a plus b the whole cube. Another way to write this formula would have been a cube plus b cube plus 3ab a plus b. That is also a plus b the whole cube. But this is same as this. If I open the brackets and instead of a I write x and instead of b I write y, I will get the same thing. So you need to remember these new formulae. And you will recognize it. Whenever you see 3 and 3, you will remember it's a cube formula. And in the denominator, definitely if there's a minus sign, it will be x minus y the whole cube formula. Same way here. Now taking the cube root on both the sides, the cube goes away. So I'm left with this. Now do componendo dividendo. You can do cross multiplication also, you'll get the right answer. You want to try that? Okay, go ahead, do that. Cross multiplication method. I'm doing componendo dividendo. So I'm left with 2x upon 2y equal 2m upon 2n. 2 gets cancelled, cross multiply, and you get what is asked.
Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.